Hey, welcome to Tricksaw. In this video, we'll be taking a look at both of the fundamental theorems of calculus. Let's start out with the first fundamental theorem. Imagine we have a function g and a function f so that g prime of x is equal to f of x. What this means is that g is the antiderivative of f, so that the bounded integral from a to b of f of x is the difference in the antiderivatives evaluated at the bounds. So it would be g of b minus g of a. So all the first fundamental theorem does is that it states what a bounded integral means, or a definite integral. Let's apply this. Over here we have the question, the definite integral from 0 to 2 of 3x plus 1 dx. So if we're saying our function f is 3x plus 1, and we need to find g so that g is the antiderivative of f of x. Using the power rule, we can find this to be 3 over 2 x squared plus x. So now we can evaluate the integral. It should be g of 2 minus g of 0. And let's plug it in. So it's going to be 3 over 2 times 4 plus 2 minus 0. So it's going to be 6 plus 2, 8. So our final answer is 8. So the reason you need to know the first fundamental theorem of calculus is for solving for definite integrals, which is when the integral has a lower bound and an upper bound. Let's move on to the second fundamental theorem of calculus. We can explain this theorem using an expression. What is the derivative with respect to x of the integral from any integer a to x of a function f of t dt? Well, according to the second fundamental theorem of calculus, it's equal to f of x. And this tells us two things. First of all, the derivatives and the integrals, they cancel out. But also, you may notice our function f, it starts evaluated at t, but it transitions to be evaluated at x. And that's because the upper bound of our integral is x. So the value is dependent on our variable x. But what if the upper bound was something like x squared? Well, then we would use the chain rule. We'd have to multiply our final answer by the derivative of our upper bound. So our final answer would be f of x times 2x. Let's see how we can use this theorem to solve a practice problem. Our question reads, g of x is equal to the integral from 2 to x of t squared plus 3t plus 1 dt. Find g prime of x. Well, this is a really simple question if we know the second fundamental theorem of calculus. The answer is the expression inside the integral evaluated at x instead of t. So our answer would be x squared plus 3x plus 1. Now, evaluate g prime of 5. So g prime of 5 is equal to 5 squared plus 15 plus 1, and that's equal to 41. So that is how we can apply the second fundamental theorem of calculus. And this is when you start learning about integral calculus and how it ties back to differential calculus. Thank you for watching this video. If you have any questions or any other calculus concepts you'd like me to discuss, just leave a comment down below. Thank you for watching. Make sure to subscribe.